Hi, everyone. So as Pranee said, my name's Annie. More officially, it's Marianne Hartley. But I think everyone of you know me as that person who messed up her visa to the UAE. And I'm really sorry for ruining the vibe with my Zoom presentation, but what can I do? So yeah, because I don't really know what was covered in the previous sessions, I really try to minimize the risk of redundancy. And I'm taking a purely like use case perspective to try to highlight some of the issues that I see in the field when I'm trying to implement collaborative learning. And I'm also focusing on a field that I think has the greatest potential impact for collaborative learning, which is healthcare in resource-limited settings. Okay, so what I'll first do is I'll just introduce a little bit to my group and our work. And then we'll go through these like 3 use cases that I think highlight some real world needs for several things that I think you've already been speaking about this weekend. And those things I also saw in the agenda. They were like incentivization for participation, also interoperability of data between clients, the need for interpretability of the models that are produced in collaborative learning and the personalization of those models. And then also the need for efficiency or optimization of communication during the learning process. So some of the use cases, the first one is I think a very good example of the need and just the scale of incentivization needed for collaborative learning. It's from my experience during the Ebola epidemic in Sierra Leone, which actually also inspired me to start working on the problem. And then an analogous issue in a project I'm working on now, which is more on an image data set as opposed to the tabular data set here. And then finally, actually a project that I'm working on with Pranee, who just introduced me. It's a project that is using a tool with Médecins Sans Frontières, or Doctors Without Borders. And they're always working in very remote and places where there's like very low reliability of communication. And it's a very good example of the need for efficiency and optimization of communication in these low resource settings. Okay, and then finally, if there's time, I'll just quickly give you a sneak peek of a distributed collaborative learning platform that I'm helping on with Professor Martin Yagi. Some of you might know him. It's called Disco. And I actually work quite closely with Martin at the Swiss Institute of Technology, or EPFL. And it's where he hosts my research group. My research group is called Intelligent Global Health. So we're really focusing on these low resource settings and to try to make and also implement machine learning tools to improve clinical practice. And there's 2 main things that we try to do. We try to better represent neglected needs or populations, and then also replicate expertise or maybe expensive tests or something that's missing as a resource in these settings. And, to do this, we actually have to collect the data ourselves often because it just doesn't exist. And then, of course, develop the model and then put that in an app. And then we have to go back into the field as well to those places to then try to implement the tool and make sure that it's actually working and doing some randomized control trials. And throughout this process, we really do a lot of work actually on capacity building, both clinically to improve the clinical practice as well, but a lot of research as well. And we feel this is a really important and valuable aspect of implementable ML, because it actually also then improves our data collection for the future and makes us kind of like a really positive feed-forward loop. So how this looks is just, this is, for instance, some snapshots of the road to one of the hospitals that we have one of our major sites at for data collection. It's really rural and extremely remote sometimes. And some of the activities we're doing, you can see like this is what we mean by capacity building. So we certify our doctors to collect, for instance, standardized like acquisition of our data. This is for the tuberculosis problem that I'll speak about later. And we also sometimes do some pretty hardcore infrastructural capacity building to make sure that they have the needs to actually collect the data and implement the tools as they're intended. So that's one of our sites. You can see why we're kind of naturally interested in collaborative learning, because it's just the nature of our work that we have to collaborate with a lot of different people in different and difficult places. It's all of our work is focused in Africa, and it's often really difficult to share data. So even as a research group, we ourselves are a use case for collaborative learning, you know, so it's very interesting to us just naturally. But the project that really, the specific one, you know, that sparked my interest was one in West Africa. When I started, I was actually deployed in Sierra Leone during the Ebola epidemic in this small little Ebola treatment center in Port Loko. And that was just one of just hundreds of Ebola treatment centers during the epidemic. And they were all run by this chaotic mix of different NGOs and governments and even foreign military. You know, so you can already see the use case here for non-IID data and a high risk of systematic bias of the data that actually was collected. So if you go back to that time, I mean, in 2014, all we knew about the Ebola epidemic at that time when we were deployed was that there was this really high mortality, unknown mechanism of transmission, was just highly contagious and with pandemic potential, no vaccine, no treatment. This may seem quite, let's say, it might remind you of other things that happened recently, but I assure you that this was a lot more scary. And actually, it was you know, really visceral. Like 23% of the entire healthcare workforce actually died. If there was ever a case for natural incentivization for trying to collaborate and learn together something to improve not only you know, the safety of patients, but the safety of the people even collecting the data, you know, this was the use case, right? We had all the ingredients. We had humanitarian actors. We had a clear and shared goal. We had really catastrophic consequences of non-collaboration. We had public pressure to share data, and even standardized and well-defined features to collect that were standardized by the WHO. But, you know, to my horror, and to many other people's horror as well, almost no data was shared or made public during the epidemic. And, you know, this was actually cited as a cause for the epidemic in the beginning. And the WHO made quite a few investigations as to why no one was sharing their data, even under these conditions. And, you know, a lot of the reasons were quite obvious. They did these massive surveys across all of the NGOs, and I just kind of summarize them here. But the ones that we already know of, you know, ethical constraints, what is privacy anyway? You know, how long does privacy last for when we share our data? Because it evolves. Is it legal to share it? Is it my responsibility to go and apply for all of these ethics approvals? Is it even my data? So ownership. And those were the real practical questions that were being asked on that aspect, which I think we tend to cover quite well in collaborative learning, the privacy aspect. But there were also some issues about quality, and this is something that we often assume as a given when we do collaborative learning, is that that harmonization is already done. And actually, you know, the actors are scared that their biases in their data may actually cause problems in the final model. They also are scared of responsibility for the quality of their data, and they're scared to share it because of that. And something that I found quite shocking, but very prevalent, was this persistence of concerns about intellectual property. People were collecting data, and they had this kind of this attitude of, yeah, I'll share my data, but after I publish my paper, right? And that really persisted for quite a long time. And then obviously there's this lack of infrastructure to where do I share it? How do I share this data, and to whom? And in what format should I share it? So the WHO made some centralized kind of solutions to this problem. They supported an effort called IDDO, which is the Infectious Disease Data Observatory. It was run by the University of Oxford, and they did a great job. They really tried to make the central repository to answer the question basically for this lack of infrastructure. Like they are the people to whom it should be shared, and they kind of standardize some formats, etc. They also did other things. They did a huge amount of work for having a huge team dedicated to harmonization and aligning all the different data sets. And then they also addressed like this ethics and legality problem where they facilitated the approvals and eventually gate-kept the access to the centralized data set. Right, so what they couldn't do, however, was protect intellectual property, because once you share the data, of course, it's shared. So people can do what they like. So despite all of this, really huge effort, it actually took 3 years for them to even receive the data, and that only represented around 20% of the collaborators. And then once they received it, it took nearly a year to harmonize that data from their team. And it took, when I applied, I was the first person to apply, 6 months to process my application as a researcher. And then we received it in 2019. Now, this is not to say that they did a bad job. They did an excellent job. And they really provided a huge and very valuable data set. But these delays were obviously unacceptable. There were several Ebola epidemics in the interim. And we need to respond more quickly to this. And you could argue that collaborative learning would be a way to do that. However, you kind of have to understand what the delays were for, so that we can also integrate that into our collaborative learning solutions later. So there was an investigation by IDDO as to why people, there's a low participation and took this long. And it came back to that same problem of intellectual property, something that really can't be ignored. And just to give you kind of like, again, this use case perspective, what intellectual property looks like from people collecting the data, it was really this kind of dominoes effect problem, where people were collecting this, let's say, tabular data set. They were collecting some boring symptoms, maybe. And one maybe very cool thing that they found was, they found funding for, and they had this expensive test that was high resource. And what they did was they went and, fine, they quickly published their paper. They used these things to predict this as a label, and they published the paper. Now they should be ready to share their data. However, what happens is this kind of dominoes where they go, oh, but you know what? I actually also want to go and investigate this in the Ebola negative patients and, look at something else. And so if they share their data set, they give up their opportunity to then do sub-analyses that can go on ad infinitum. And that's really the practical issue of why people want to protect their intellectual property. And I really think that one of the coolest things about collaborative learning is that we have this opportunity to provide fine-grained control over the definition of what is a feature and what is a label, and to have this kind of toggling of what we consider appropriate as a task. And it might allow people to share their data or allow access to their data for models more easily if we allow them that sort of control. So I just wanted to highlight that as one of the things that I take home message from the incentivization of this. Anyway, we actually more focused, we did work on this part of it, which was trying to figure out how to harmonize data that you can't see. Because this takes a huge amount of effort and a lot of time, and this was a massive team that did it at IDDO. So how can we maybe automate this process? So, if you've ever done harmonization of data, you'll probably know that making sure that it's interoperable, that you can detect biases like this, compared to the rest of the maybe other data sets. You need to see the data. You'd appreciate that. You'd need to interpret it and just visualize it to really understand shifts in data so that you can maybe normalize features to each other, etc. So how can we do this? We tried. We submitted this. We presented this at the ICML-FL workshop last year, and we were asking the question about how can we firstly detect the biases, and then once we've detected them, can we correct them? And once we've corrected them, can we make sure that we can interpret them even without seeing the data to make sure that they actually make sense to people on the ground who collect the data, so people can feel comfortable with the transformations in the data that had taken place. So we proposed this thing called IFED average, which is just basically an extension of federated averaging, where we can make interpretable data interoperability for federated learning. So what that actually means is we try to take a simple approach to this, where if these are the users in a federation, And this is just zoomed in on one of these little users, and that's your server over there. Our architecture basically said, well, here's a shared model. What we're going to do is just make like little input, a local input layer when they're locally learning, right? And a local target layer. And we can learn for a tabular data set, for instance, the weights and biases of individual features that are going into the model. And so when we learn these feature-wise weights and biases, we can actually compare them with other users and then make these heat maps that allow us to then visualize these shifts in the distributions of individual features. And that can start a conversation with people. Can say, hey, I see that I don't know your data, but I see that your data has got this systematic shift, right? What's going on? Let's try to investigate it. So what we found was, like, for example, in the Ebola data set that I finally got access to, this is it. So here you can see the different users in different towns in Sierra Leone. And here are the different features, for instance, age and referral time to the hospital. And this is a PCR data, like whether you have Ebola or not. So it's a continuous feature. And you can see that Freetown had a PCR value that was just off the charts compared to other places, right? And this was, we could actually investigate it then by, if we wanted to just show some distributions, we could actually see that Freetown's Ebola PCR was systematically shifted to one side. And it was, when we asked the people, the data owners about it, we could then say, hey, what's happening with your PCR machine? And they actually had a calibration issue that was known, but was not harmonized for. And this was after all of the harmonization efforts that took place by IDDO. So this shows that we can actually still detect systematic shifts in the data, even when we don't see it. And we can detect it. We went a little step further to also try to then correct for it, and then make this kind of detection of interoperability issues into an opportunity for personalized models. So we made these biased adapted model personalization tools, where we basically had two tasks of either predicting diagnosis or the prognosis of Ebola. And when we compared it to a centralized model, we got these kind of values and ORC for just a general model for these difficult tasks. And we compared that between local and centralized, federated averaging, and a common personalization model for federated learning. And we found that when we adapt our models according to biases, we can actually better match and even outperform centralized and local baselines. So there's a value to doing this automatically, and it might also cut out a lot of the effort that's required to kind of submit or make your data available for collaborative learning. Right, so I won't go into this task very deeply, but that was easy, right? That was a tabular data set. It's kind of easy to extract interpretable features that are already named. But what is a feature in a image data set of ultrasound, or of a sound data set of lung auscultation sounds that we're collecting in the study that we're running at the moment? So right now, how do you even make that interpretable? So our current method that we're trying to do to make sure that we're standardizing the data is to standardize its acquisition. So we do that, we train all of our doctors and certify them, and we make sure that they're all using the same probe in different places and have like a certain protocol that they're following to acquire the data. And, it's great because they're doing it in a very controlled fashion, and we can get really nice results for predicting tuberculosis, just using these images, for example, from ultrasound. But this is because we have the luxury of sharing the data at the moment, right? So when we share the data, we see that, not everyone behaves in the standardized fashion, as you would assume, despite our huge efforts for training. And we saw that some people even write in the actual labels for our tasks. And obviously we can't use data that's critically unusable data. And if we hadn't seen this, we would actually go and learn this leaky data, right? So what we're doing right now, and maybe you have better ideas, and maybe as a workshop you can help me think of another ways to do it. But what we're trying to do right now, it's ongoing work, but to take this data, this is just a made up graph from, like, the inspiration from Ebola, and to try to kind of featureize the images into things that we can understand, like tabularize it. So greenness, blueness, the amount of text, so textiness or whatever, and to detect biases in the same way. Okay, I won't go into that one, but I just wanted to quickly touch on this because I thought it was interesting as another use case before I end. And it's called Antibiogo, as I said before. This is what the task is. It's basically, this is a lot of bacteria that's put onto a plate, and we try to grow the bacteria in the presence of these antibiotic discs. It's paper soaked in antibiotic, and we see how closely the bacteria dare to grow around this antibiotic disc. Here, they don't care about the antibiotic, and here the antibiotic is killing them. It's actually quite difficult to interpret this laboratory test, and MSF Foundation is trying to automate this process. And they basically have this now. We're working on it with Praneeth, this app that now goes and takes a photo of these tests, and then first tries to identify each of the discs because they have this text on them, which is our main task here, by the way, and then also just tries to measure the zones around the little discs, right? So this is great, it works and everything, but the issue is that they need continuous learning, which is what we're also trying to implement now, because the brand names of those little discs might change, there might be new antibiotics, we need to learn things. But we can't share data, so perfect example of collaborative learning necessary. And another problem is that we can't learn, we can't just do collaborative learning like general federated learning easily in this environment, because it's MSF and they're working in strange places that don't have communication very reliably. So with this network reliability and also the cost of sharing, especially image data, we can't just go and share it in models as well. So what we tried to do was we focus on that task of identifying the antibiotic name. And if you just look on this side, we're trying to identify this. We make like basically a model that actually computes something that's much lower dimension, much simpler, and can be offline and online. And what we do is we call something called prototypical learning, pretty much analogous to like k-nearest neighbors, where you're basically taking maybe all of these API images, and then they are recognized as being very closely together, and they can be kind of clustered, and a prototype is then computed, which is the prototypical image of this group of labels. And in reality, if we see what we're doing here, it has a lot of advantages to compute prototypes, because you can actually compute them very locally if these are all the different phones that are collecting the data. When it's offline, you can actually compute your local prototypes continuously, right? So you can get new images, and you can measure the distance of these new images according to your prototypes, and actually learn one-shot learning, if you wanted to, when it's offline. And when it is online, eventually, all you have to communicate is your prototype, rather than having this multiple rounds of communication for normal federated learning. So when it's online, you just share your prototypes, and the prototypes then can be computed before they are checked and pushed back to the model. So you update your understanding of the prototype map. And yeah, so this is multiple advantages. It can be one round learning, so you only communicate once. One shot learning, because you can kind of see a new image in relation to its like space in your prototype space. And there's also this offline option. So I'll stop there because I'm nearly at time. But maybe if you wanted to see, I just also invite you to kind of look at one of our what we're doing in the lab with Martin as well. It's DISCO, distributed collaborative learning. You can see that it's kind of targeted to very novice users, explaining what collaborative learning is, and making it a very kind of easy interface. And you can either train and join a Disco collaborative or validate your model for testing it, or you can create your own model and upload that and invite other people to join the collaborative. How it works is you can basically just train. We've got a few models that we've already uploaded here. You can see there's like quite a few different ones, and we describe what they do. And this is one that of the ultrasound, actually. You can see that we've described the task and whatnot. And then, yeah, you can see that we describe the data format needed, the example of the data that you should upload, and make it really easy for you to just participate in collaborative learning like this. So you can just go and like select some images that are of a certain label, drag and drop, and do it for the other label. And basically you can then just go ahead and train models with peers that happen to be online as well. And you can either train alone or train collaboratively. And something, when we talk about train collaboratively, I'll just go to the next slide. Something that's maybe unique about what we're doing is that it's both federated learning in the collaborative, and we use like various privacy controls. If you're interested, we can speak about that, using a server. But then we also have a completely decentralized option with no server, where it's just direct peer-to-peer communication to learn the joint models. So if you want to know anything more about that, please feel free to ask. But I think I've reached my time, and I'll let you go back to your life in 3D shortly after this. Yeah. Thanks.
Thanks, Andy, for the excellent talk. Are there any questions in the audience for Andy? Okay, I think you can. You should be able to just speak, and the mic should catch the voice.
Yeah, I can hear everything. It's good.
Thank you for the interesting presentation. For the anti-biogen project, did I get it right? What's
enough.
what's the privacy concern related to that data?
Yeah, it might be strange to think that just a little photo of the antibiotic disc is private, but actually it's actually very difficult to share the data coming from medical hospitals in general. And also because they're working, MSF is working in kind of war zones and politically kind of inflammatory environments, they actually are not allowed to share any data from any of their hospitals. So it might not be the actual nature of the data, but it's actually the context that the data is in that makes it very difficult to share. Later on, actually, it also gets not just the name of the antibiotic, but the presence or absence of multi-resistant bacteria are also things that sometimes people don't want to share. Yeah, so for political reasons.
And well, first of all, thanks. It's very, very inspiring and a nice presentation. So concerning again the unreliable connection that you have due to several reasons. So do you deal also with the problem of asynchronous learning? So asynchronicity in the updates and what you receive, something that is relevant to your project?
It's really relevant, right? Because the communication network is unreliable, and some people may also be in different time zones, and they certainly aren't connected all the time. In Disco, for example, this is not the same project, but we are also very interested in this asynchronous and like let's say infinite learning. So there you can just kind of deal with it by waiting forever, right, for the update. But yes, asynchronous learning is actually not a problem for the project that you mentioned, because we can just update our prototype maps whenever, right? So because it's one round learning, what is synchronicity in one round learning, right? Because you only have to communicate your prototypes kind of once almost to update them. So there's not this like concept of multiple rounds. And you can just maybe think of it as a much longer scale learning process. Yeah. So it's a very interesting use case for synchronicity, actually.
Thank you.
Yeah, so yeah, it's a nice talk. Due to my lack of understanding of the healthcare aspects, I'd like to know if there are situations where the labels would lie on a different client as opposed to the features or the images. Because typically I'd assume everything happens in the same hospital or like the health organization where they lie in the same place, but you're looking at more humanitarian, more niche use cases. Does this really happen with the client and the labels are on a different client or on a different server or on a different device?
So that's an interesting kind of like special case of vertical federated learning, right? So horizontal federated learning is, of course, where you're collecting the same features, but different patients. So in other words, if you've got a tabular data set, it's kind of someone has got this set of patients and another person has this set of patients, right? And that's horizontal federated learning because you're kind of cutting the data set in this way. But vertical federated learning is where two people have got completely different feature spaces. And maybe one person has got the label of that. I find that a very, very challenging problem because if you want to do vertical federated learning, we're working in the space right now where we're taking a highly modular approach. So we're learning to kind of go a step further from what I just showed you, where we were learning like the weights and biases for each feature, right? Now we actually learn a model for each feature. So we have this modularization of of the data set where each feature, so if one user has got this set of features and another user has got this set of features, we make a little module of a model for each of the features here and for each of the features here, right? But what you've asked is making it even more difficult, which at least in our scenario, we've got each of the users sharing a label, but with different features, right? And then we can kind of make a model that can decode the shared label. But you've made it very difficult, and I don't like your scenario at all because it makes it extremely difficult for our models to learn. But yeah, I think modularization is still a real opportunity. Maybe it could work in that scenario. Yeah.
Yeah, I mean, this is a problem that shows up often like tech companies like Facebook, because they're for whatever their business reasons, the labels are private and on a different device. While the features are within their own servers because of their behavior on the tech platform. I was interested if this is a more real use case outside the tech company space, like healthcare setting.
No, it is. I would say it's more of a high resource setting concern than a low resource setting concern, just because to have a health record that's going between two hospitals that are collecting different things requires a certain amount of synchronicity between hospitals, right? So it's more of a high resource setting concern where someone has got diabetes and they go to like some diabetic clinic and then they go to the headache clinic, and now there's two different labels in two different places and two different sets of information. And there's this concept of linkage where you can link one patient between two facilities collecting two different things. So that's one thing that I would just say that it's a high resource setting concern more than a low resource setting concern. Yeah. But it's an interesting use case. And I think modularity is the answer. Yeah.